Hi everyone, in this video we are going to discuss about second part of module 3. Second part of module 3 is transient analysis. So in transient analysis we have different topics. One is transient analysis of RL circuits, transient analysis of RL circuit, resistor and inductor series circuit, and transient analysis of RC circuit under DC excitations. DC excitation. Behavior of circuit elements under switching action. Switching action means when switch is closed, switch is on, switch is open, those conditions, switching actions. Evaluation of initial conditions. So, one switch is open, switch is closed. So, those evaluations we have to do in details for circuits, RLC circuit, RL circuit, RC circuit, RL parallel circuit, RC parallel circuit, different combination circuit we have to do the evaluation of initial conditions. Based on that we'll do some problems. Okay. So, this is about module 3 content, and we will move to the next what is meant by initial conditions. So, there are many reasons for studying initial and final conditions. So, for example, if you take one mission, once if you switch is once if you are off the mission, so how the mission will be there. So, once if you start the mission, how the mission will start. So, once if you run the keep on some time, how the mission behaves. So, those conditions comes under initial and final conditions here. The most important reason is that of initial and final condition evaluated the arbitrary constants. So, some constants we have. So, that appear in general solution of the differential equations. So, differential equations, why we are discussing here, arbitrary constants, those conditions we are evaluating, you are solving by using differential equation. So, that much important of differential equation. You have studied in mathematics, right? Differential equation, those techniques, those formulas here we will apply. So, we will apply for the circuits, RL circuit, RC circuit. While you are solving the problems, you come to know how much importance of differential equations. So, differential equations are much important for electrical students. So, not only for this subject, some other subjects also will use the differential equation. What is the differentiation of x, differentiation of x square, differentiation of sin x, differentiation of cos x, and double differentiations, d square x by dt square, d square t by dt square. What is the differentiation? Differentiation of u by v method, differentiation of u v method. Those methods here we will use and we will solve the problems. Okay, that is about differential equations used in this module. And in this chapter we concentrate on finding the change in selected variables in the circuit when switch is thrown open from closed position, or vice versa. When switch is open, how circuit will behave, when switch is closed, how circuit will behave. So here we are taking for identification. So, we are taking t is equal to 0, t is equal to 0 minus, t is equal to 0 plus, t is equal to infinite. So, initial conditions means t is equal to 0. Initial condition is we must take t is equal to 0. So, in t is equal to 0 also again two sub conditions we have, t is equal to 0 minus, t is equal to 0 plus. T is equal to 0 minus means the switch is just open, t is equal to 0 plus means the switch is just closed. Okay. So, next one t is equal to infinity, t is equal to infinity means the switch is closed for some time. So, switch is closed for some time. So, those type of conditions here we will apply and we will use. Here finally what we can say that thus a switched circuit is an electrical circuit with one or more switches that open or close at the time of t is equal to 0. So, either it may be open, either it may be closed. Open means what we can say, t is equal to 0 minus, close means what we can say, t is equal to 0 plus. 0 plus indicates close, 0 minus indicates open. Okay. So, those conditions here we will see for RLC elements. First element is here we have the inductor. So initial and final conditions in the element the inductor. So inductor we are connecting to the DC voltage source and through this one switch. So switch T is equal to 0. So here T is equal to 0 means switch is open condition or closed condition. Based on this T is equal to 0 minus T is equal to 0 plus we have to consider. So what is the initial condition? What is the final condition for inductor? How we will calculate? So based on the current equation of the inductor, we can say that switch is short circuited. Inductor is short circuited. Inductor is open circuited. So first we will see the how parameters we will use for this inductor initial and final conditions. The switch is closed at T is equal to 0, hence T is equal to 0 minus corresponds to the instant when the switch is just open, at T is equal to 0 plus. So T is equal to 0 minus corresponds to the instant when the switch is just open, and T is equal to 0 plus corresponds to the instant when the switch is just closed. T is equal to 0 represents the just closed, and T is equal to 0 minus represents the just open. So here current through this inductor I is equal to 1 by L integral minus infinity to T. So this formula we have to use this formula. So next one, once after using this formula we have to change the limits. Here we have taken limits are minus infinity to plus infinity. So here limits are minus infinity to T or infinite. So here we are taking T. So what we will do, minus infinity to minus 0 is one limit, minus 0 to T is one limit, another limit. Those limits we will take and we will solve the initial conditions. So here we are changed the limits minus infinity to 0 minus and 0 minus to T. So minus infinity to 0 minus, which is open, there is no current. So that's what here I of 0 minus we have represented. So 1 by L integral 0 T is equal to 0 minus to T. So T is equal to 0 plus. So both the sides if you take in place of T you substitute 0 plus both the sides. So I of 0 plus I of 0 minus plus 1 by L 0 minus to 0 plus. So here in this case this will be equal to 0. The current flowing through the inductor is just to close condition T, just to close condition inductor current will be 0. That's what so inductor acts as a open circuit. So here I of 0 plus is equal to I of 0 minus. So these are the conditions. So what we can say in graphical representation, we can see the inductor positions. So here in graphical representation, so inductor L. So when L is inductor, so at T is equal to 0 plus, it acts as a open circuit, and inductor L at T is equal to infinite, it acts as a short circuit. So it acts as a short circuit. So what we can do, initial and final conditions. So initially inductor acts as a open, finally inductor acts as a short circuit. So these conditions will apply in problems. Okay. Next we will move to the capacitor. So before going to the capacitor, so we will once again we will revise this one. So in problems, especially in problems, so this condition we will use maximum. So this condition if you write in problems, you will get 1 mark. So I have 0 plus is equal to I have 0 minus is equal to same. So here inductor acts as a open circuit. This currents also equal to 0. So when inductor is there in series circuit, initially current is equal to 0. So finally current will flows. Okay. So final current is different and initial current is different. Initial current is 0. Why? Because so initially the inductor acts as a open circuit, and finally inductor acts as a short circuit. That's what these conditions we have to remember. So these conditions are very important for problem solving. And we will move to the capacitor. So in next video we will see about capacitor. Okay, thank you everyone.